Yes, students, today we are going to discuss the first chapter of second PUC, that is electric charges and electric fields. This electric charges and the fields, that is the foundation for, these are the foundations for electrostatics. What is this electrostatics is? It is a branch of physics which deals with, that is, we are going to study about the stationary charges here. Stationary means the charges at rest. Charges at rest. Every material, if we consider any of the atoms, molecules which contains positively charged protons, negatively charged electrons, right? So we can define this electric charges a fundamental property of matter that causes it to experience a force when placed in an electromagnetic field. When there is an electric charge, it may be positive charge or the negative charge, there is some field which is around it, what we call it as a electric field. So we can define an electric charge which is the fundamental property of the matter that causes it to experience a force. Because of the presence of this charge, there is some experience of some force when it is that is what we call it as an electromagnetic field. There are two types of charges, mainly we consider it as a two types of charges, that is positive charge. First one is positive charge and the second one is negative charge. If there is no charge, then we consider it as a neutral, right? So how a positive charge is formed? When a positive charge is formed, when there is a deficiency of electron from the atom. If we consider an atom which is a nucleus here and electrons are revolving around it, if there is a deficiency of the electron, that is one electron is removed, then it will become a positive charge. When there is a deficiency of electron, whenever there is a deficiency of electrons, then we refer it as a positive charge. Negative charge means whenever an atom or a particle gets the negative charge when there is excess of electrons which is more number of electrons, that is if that number of electrons are excess for that particular particle or the material, then it is referred as a negatively charged. Always we will tell the like charges, it is a property of charges also, like charges always repel. Like charges always repel. Unlike charges always attract each other. Like if we consider a positive and positive charge, it will always repel each other. If we consider a positive and the negative, the force will be attractive force between them. So always the like charges will repel and unlike charges will attract each other. Whenever the charges are at rest, the force between them are, when we are considering with the charges which are at rest, we are dealing with the electrostatics. It is a branch of electrostatics. Electric charges in terms of electrostatics we are going to study here. So whenever there is a charges at rest, the forces between them, if it is not moving, the force it may be attractive force or the repulsive force. These forces can be defined or explained, described by the law, what we call it as a Coulomb's law. We are going to study this Coulomb's law in this chapter in detail. The influence of a charge exert in a surrounding space whenever there is a charge which is at rest, there is some influence of that charge around this space, right? That's what around the surrounding, what we refer it as a electric field. Okay, we call it as a electric field. In this chapter, the electric charges and electric field, we are going to discuss some important concept of this, important concepts. We are going to discuss in this chapters are that is properties of electric charge, properties of electric charge and its behavior, Coulomb's law, principle of superposition in this, and concept of representation of electric field. We are going to study about the electric field lines, also electric flux. We are going to discuss electric flux, about the electric flux, and also Gauss law and its applications. In the first chapter, electric charges and electric field, we are going to discuss mainly these things: properties of electric charge, Coulomb's law, electric field lines, electric flux, Gauss law, and its applications in detail, the application part. So we are going to discuss about these now. Before going to the Coulomb's law, we will discuss about properties of electric charge. First, we will discuss about the properties of electric charge. Properties of electric charges. These charges, we can summarize some few points for this. They may ask you for the 2 marks. Mention some properties of charges, 2 or 3 mark question. This is first one is additivity of charges. First one is additivity of charges. That means charges, we can add the charges, like if there is a charge of 1 plus 1 coulomb and a charge of plus 5 coulomb, then we can tell the total charge is plus 6 coulomb, like that. If there is a charge, there is some charges like q1 as minus 5 coulomb, q2 as plus 2 coulomb, the total charge we can tell it as q1 plus q2, that is minus 5 plus 2 coulomb, that is minus 3 coulomb. So like this additivity of charges, you just mentioned, they will ask for 2 marks or 3 marks. You have to mention the properties of charges, like you can write charges are additive or additivity of charges. Second one is charges are conserved. What is the meaning of conservation of charges? We cannot never destroy a charge, we can never create. So like that, they are conserved. If there is a loss of charges from some material, it is gained by another, like that. Charges are conserved. Third one is quantization of charges. Quantization of charges means we can have only the 1 coulomb of charge, that is of plus q plus 1, if we can tell q is equal to 1 coulomb. We cannot have half of the charge or 3/4 of the charge, like that we cannot have. It is the integral, that is the total charge can also be the multiplication of n into e, that is n can be only 1, 2, 3 etc., or there is no charge, like that. So it is the multiplication of a particular whole charge. We cannot tell it is a half of the charge, like that. It is a quantization. Okay, next third one is quantization of charge. Next, fourth one is the property we already discussed, that is like charges always repel, like charges repel, and unlike charges or the opposite charges which will attract each other. This is about the basic properties of the charges. So there are main four properties: additivity of charges, you can tell charges are conserved, quantization of charges, like charges repel, and unlike charges attract each other. Next, there is a concept of gold leaf electroscope. They may ask you for the MCQ or 1 or 2 marks, or they may include about this topic, that is gold leaf electroscope. So this gold leaf electroscope it is a simple device used to detect the electric charges. It is used to detect the electric charges. It consisting of a metal rod and two gold leaves. Like it is consisting of a box and a metal rod, and there are two gold leaves here. Metal rod, this is the metal rod inside a box. Okay, inside this box, and when charge whenever the charge which are come in contact with this, these leaves are going to diverge. If there is more divergence in the leaves, this gold leaves, this is metal rod. So if there is more divergence in the gold leaves, then there is more, this means more number of charges. So this gold leaf electroscope is mainly used to detect the electric charges which are going in, incoming electric charges. Whenever there is a more number of gold leaves, the divergence is more, then we can tell the charges are more. Okay. Next, we can see why we can discuss why this material acquire the charges. We have some number of charged materials in the nature, right? So why these materials why materials acquire charge? Why these materials acquire charge? Because all matter we are going to discuss, those matters will be made up of atoms or the molecules, right? These normally atoms we are going to see they are in neutral, but rubbing, that is there are number of processes, that is charging methods, that is charging by induction, charging by conduction, charging by rubbing. So we are going to discuss now about the rubbing. When we are going to rub one material with the another, like example, if in this process if there is a number of loss of the electron is going to takes place from the material, if we consider any of the material and there is a loss of the electrons taking place, this material acquire a positive charge. If there is a gaining of electron in the process, then there is more number of negative charges on the material, so it will acquire a negative charge. So loss of electrons makes the object positively charged, and the gaining of electron makes the object to the negatively charged. If we consider an example of rubbing a glass rod, if we consider this as a glass rod, if we rub this glass rod with a silk cloth, then glass rod, if we rub this silk cloth with the silk cloth to the glass rod, the loss of electron from the glass rod makes this glass rod as a positive one. Okay, the gaining of electron, while this process silk cloth gains an electron and it becomes negatively charged. So it is a charging by rubbing. Okay, so by rubbing a glass rod with the silk, the glass rod gains the electron, that is, sorry, loses the electron and it becomes positive one, and silk cloth gains the electron and it becomes negatively charged. Okay, there is a concept of conductors, insulators and all. You know, right? Conductors, insulator, I think you know. Let us discuss it briefly. Conductors means, we should know this, conductors means which allows the electricity to pass through them. Whatever the material which allow the electricity to flow through them easily, we call it as a conductors. Okay, example, metals, it may be metals, human body, earth, etc. Okay, insulators means which refuses or resists the flow of electricity through it. So which resists the flow of electricity, we call it as a insulator. For example, rubber, wood, plastic, etc. Insulator, we can tell. Okay, next, charge distribution. If we consider the charge distribution on this conductors and the insulators, okay, when we are going to give some charges to the conductor, charges will spread over the surface of this. Okay, when we consider the insulator, it will remain in the same spot where we have given the charges. So the charge distribution, charges will be there at the same spot, but here this will be on the conductors, which will be distributed, spreads on the surface of the conductor. Next, here we are going to discuss a main topic of this chapter, which is very important one, that is Coulomb's inverse square law. We are going to discuss Coulomb's inverse square law. Coulomb's inverse square law. Coulomb's law explains the force between the two charged particles, which is stationary, which are at rest. So this Coulomb's law, Coulomb's inverse square law, explains the force between the two charges which are at rest. Okay, it was formulated by Charles Augustin de Coulomb in 1785. Okay, it looks similar to the Newton's law of gravitation. Newton's law of gravitation. It looks similar to this, but here we are referring with, it is not about the charges, Newton's law of gravitation. So here in the Coulomb's law, we are going to define or explain about the electric charges, force between the electric charges, not about any mass or the earth or the other particles, only for the electric charges, force between the electric charges. Okay, the statement, let us see the statement of this Coulomb's inverse square law. The electrostatic force between two-point charges is directly proportional to the product of magnitude of charges and inversely proportional to the square of the distance between them. So the electrostatic force between the 2 point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. So it's always another point, it is always acts along the line joining between the 2 points. If we consider the two charges, which is q1 and q2, it always acts between the line joining the two charges. Okay, it may be repulsive, it may be attractive force. It depends upon the which type of charges you are defining, like charges or the unlike charges. The mathematical form can be written as F is equal to K into Q1 Q2 by R square, mod of this Q1 Q2, mod of Q1 Q2 here. This force is the electrostatic force. Electrostatic force, this is the electrostatic force, and this q1 q2 are the charges, magnitude of the charges, magnitude of the charges. R is the distance between the charges, the distance between q1 and q2. Okay, this K is nothing but 1 by 4 pi epsilon naught. Epsilon naught is the permittivity of free space. Value of this is 8.854 into 10 per minus 12 Coulomb square per Newton per meter square. Okay, the value of K is, that is 1 by 4 pi epsilon naught, right? The value of this K, 1 by 4 pi epsilon naught, the whole value of this is 9 into 10 per 9 Newton meter square per Coulomb square. So this is important for all the problem solving and the concept of this while solving the problems in the electric charges and electric field. So this is important. You can directly substitute 1 by 4 pi epsilon naught, the K value, as 9 into 10 per 9 Newton meter square per Coulomb square. Okay, the value of this, which is in vacuum, the value, this is in vacuum. Okay, this is about the Coulomb's inverse square law. So this is very easier and very important for the 2 marks. Okay, they also tell you to write the which is that vector form of this Coulomb's inverse square law for the 1 mark, or they can add along with the other question. So Coulomb's inverse square law, we can define the force which is always proportional to the product of magnitude of the two charges, and it is inversely proportional to the square of the distance between those two charges. It may be repulsive or the attractive, that depends upon the which type of charges you have used here. Okay, q1 q2, if this is a plus, it may be attractive one. Okay, the force will be the attractive force. If the plus and minus, if opposite charges, or plus, it may be repulsive one. So it is always acts along the line joining. Okay, if they ask you to write the Coulomb's law, the vector form of the Coulomb's law, we can write F vector is equal to 1 by 4 pi epsilon naught, that is the K value, q1 q2 by r square r cap. Here we know 1 by 4 pi epsilon naught. Just now we have discussed q1 q2 are the charges, that is the magnitude of the charges, product of magnitude of the charges. R cap, this is the unit vector. R cap is the unit vector in the direction of force. Okay, epsilon naught is the permittivity of free space. So R cap is the unit vector along the direction of force, and this is what the Coulomb's vector form of the Coulomb's law in vector form, which is also the important one. We can define a 1 Coulomb here. See, if they ask you to define the unit, that is a unit of electric charge is Coulomb itself, and then law name is also Coulomb. The SI unit of charge is Coulomb. We represent it by a capital C. Okay, how we can define a 1 coulomb? So we know the equation F is equal to, right, K is a constant here. Okay, K Q1 Q2 by R square, right, Q1 Q2 by R square. So if we are going to define a charge of 1 coulomb, if this two charges, if we consider the two identical charges, Q1 and Q2 are the identical charges separated by a 1 meter in a free space. We consider in a free space this one identical two charges Q1 and Q2 separated by a 1 meter distance, then they repel each other, right? If they are plus plus, then or the minus minus, the like charges, they will repel, okay, each other with the same force of, the force will be 9 into 10 power 9 Newton. Okay, if they repel with the force of 9 into 10 power 9 Newton, then these charges are of 1 coulomb. That is, if this is a constant one, if there are two charges, okay, if this distance between the charges is 1 meter, the force exerted between them is 9 into 10 power 9 Newton, then we can tell this as the charges are with the 1 coulomb. So charge is 1 coulomb when they separated by a distance of 1 meter and force between them is 9 into 10 power 9 Newton. Okay, this is what the concept is. Now I'll ask you a question, that is, if you are asked with, if there are two charges, like for example, they ask you with this, if there are two charges, okay, one with plus 15 coulomb or another with plus 25 or coulomb or the micro coulomb, you can whatever you can take, which charge will repel more? Okay, there are two charges, Q1 is 15 coulomb, Q2 is 25 coulomb, or 5 coulomb or 10 coulomb, you can also consider. So which will repel? If both are plus, they obviously they will repel. Which will repel more? If they ask you like this, which will repel more? What is the answer for this? That is, according to the Coulomb's law, the forces are equal and opposite, right? If there are two charges, here plus 15 coulomb, here plus 25 coulomb, their force which exerted are equal and opposite. How much is the force with which it will repel with this? Same amount of the force the 25 coulomb will repel with this. So forces are equal and opposite. We can never tell the value of Q is more here, so it will repel more, like that we cannot tell like that. Okay, the forces are always equal and opposite, same amount of repel from the forces by the Q1 and Q2. Here we have discussed about the introduction and the Coulomb's law of this chapter, electric charges and electric field.